In this problem we are asked to find the derivative dy over dx given that the curve y equal to f of x satisfies the equation 8y cube x square plus 4y square x plus 3y equal to exponential of y square. This implicit equation represents the graph of the function. We need to differentiate the left-hand side and right-hand side of the equation. When we apply the differential operator to the left-hand side we have d over dx of 8y to the power 3x to the power 2 plus 4y to the power 2x plus 3y should be equal to the differential operator applied to the right-hand side, which is d over dx of exponential of y square. First, in order to differentiate both sides of this equation, we need to use all differential rules. Let us review the power, sum, and difference rules. Remark that the derivative of x to the power n is n times x to the power n minus 1. The derivative of the sum of two functions u of x and v of x is the sum of derivatives, u prime of x plus v prime of x. The derivative of the difference of two functions u of x and v of x is the difference of derivatives, u prime of x minus v prime of x. The left-hand side of this equation has three terms. We have to differentiate each of these terms. Using the fact that the derivative of a constant is always 0, and the power rule we obtain d over dx of 8y to the power 3x to the power 2 is 16xy cubed, plus 24y square x square times dy over dx. D over dx of 4y to the power 2x is 4y square, plus 8yx times dy over dx. D over dx of 3y is 3 times dy over dx. Thus, using the sum and difference rules, we add the derivatives of all these terms of the left-hand side of the equation and we group these derivatives in two groups, those that have common factor dx over dx and those that have common factors dy over dx. Then we factor out dy over dx and obtain 16xy cubed plus 4y square plus 0y plus 24y square x square plus 8yx plus 3 times dy over dx. Now, we have to compute the derivative of the right-hand side of this equation. We can clearly see that this expression involves a composition of functions. So we need to use the chain rule. Firstly, let us recall the chain rule. We know that d over dx of u of v of x is equal to u prime of v of x times dv of x over dx. Observe that, the derivative d over dx of exponential of y square is 2y times exponential of y square times dy over dx. We know that, the differential equation, d over dx of 8y cube x square, plus 4y square x, plus 3y minus d over dx of exponential of y square equals to 0, is equivalent to 16xy cube, plus 4y square, plus 0y, plus 24y square x square, plus 8yx, plus 3 times dy over dx, minus 2y times exponential of y square times dy over dx equals to 0, which is also equivalent to 24y square x square, plus 8yx, plus 3, plus, minus 2y times exponential of y square, times dy over dx, which is equal to negative the quantity 16xy cube, plus 4y square, plus 0y. When we expand after multiplying by negative 1, we have minus 16xy cube, minus 4y square, plus 0y. Finally, when we solve the last equation for dy over dx, we see that the derivative of y with respect to x, dy over dx is equal to the ratio 16xy cube, plus 4y square over 24y square x square, plus 8yx, plus 3, minus 2y times exponential of y square. Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus-related videos covering limits, derivatives, integration, and many other calculus topics.